today, let us look at arithmetic progressions. Let us look at the patterns on the screen. The first pattern is a series of ones, one grey, one yellow, one grey, one yellow, and so on. The second pattern is 1 grey, 2 yellow, 3 grey, 4 yellow, and 5 greys, and so on. The third pattern is 2 greys, 4 yellows, 6 greys, and so on. Observe that in the first pattern we are adding 0 to get the subsequent number. In the second pattern we are adding 1 to get the next number. And in the third pattern we are adding 2 to get the next number. So in the first pattern we are taking the first term and adding a 0. So the first term, small a, is 1 and the number that we are adding, small d, is 0. In the second pattern, the first term is 1 and the term we are adding is 1 as well. In the third pattern, the first term is equal to 2 and the number that we are adding to get the next term is also 2. So small a is equal to 2 and small d is also equal to 2. Such patterns are known as arithmetic progressions. We are adding a number to find the very next number in the pattern. Alright, let us try to write an arithmetic progression where the first term is 3 and the number we add to get the next term is 2. So small a is equal to 3 and small d equals 2. So the first term is 3 and the next term would be 3 plus 2, which is 5. The next term would be 5 plus 2, which is 7. The next term would be 7 plus 2, which is 9. The next term would be 9 plus 2, which is 11, and so on. If we were to denote the first term as A1, where the subscript 1 denotes first term, then the rest of the terms can be denoted as A2, A3, A4, A5, A6, and so on. Now note here that the difference between the first two terms, A1 and A2, is 2. Similarly, the difference between the next two terms, that is A3 minus A2, is equal to 2. A4 minus A3 is equal to 2, and so on. Now this number 2 or small d is known as the common difference. Let us look at a few problems. Write first 4 terms of an AP whose first term is minus 2 and common difference is 1 by 2. So we are given A1 as minus 2 and D as 1 by 2. Now we have to find the first 4 terms. So let us write A1, A2, A3 and A4. We are given A1 as minus 2. So the next term A2 would be A1 plus D. That is minus 2 plus half. A2 comes as minus 3 by 2. The next term A3 would be A2 plus D. Or minus 1. And the fourth term A4 would be A3 plus D. Or minus half. So the first 4 terms of this AP would be minus 2, comma, minus 3 by 2, comma, minus 1, comma, minus 1 by 2. Let us look at another problem. Which of the following is an AP? We are given 3 patterns and we have to identify if they are arithmetic progressions or not. Let us look at the first AP. Now recall that for an AP we should be able to identify small a and small d. that is the first term and the common difference. Now here, let us look at the common difference between the first and second terms. It comes out as -2. Let us look at the common difference between the second and third term. It comes out as -2 again. Let us look at the difference between the third and fourth term. So we get d equals -2 for all the terms. So for this progression, we can identify small a as -1.2 and small d as -2. Yes, it is an arithmetic progression. Let us look at the second pattern. Let us look at the difference between the first and second term. The difference comes out as square root of 2. Let us look at the difference between the second and third term. Let us open the bracket and get the like terms together. The difference is square root of 2. Let us look at the difference between the third and fourth terms. The difference is square root of 2. So we see that there is a consistent common difference. So here we can identify the first term of small a as 3 and small d or common difference as square root of 2. So yes, the given pattern is an arithmetic progression. Let us look at the third pattern. Let us look at the difference between the first and second term. It comes out as 0.02. Let us look at the difference between the second and third term. It comes out as 0.002, which is different from the difference between the first and second term. Since these differences are not equal, the given pattern is not an arithmetic progression. Let us look at another problem. Express this statement in an arithmetic progression. The cost of digging a well after every meter of digging, when it costs rupees 150 for the first meter and rises by rupees 50 for each subsequent meter. Now note here that for the first meter, it is costing rupees 150. So small a or the first term is 150. And it is rising by 50 rupees for each subsequent meter. So we are going to add 50 rupees for every meter that we dig. So small d is 50 rupees here. Now let us try to figure out the arithmetic progression here. Let us try to figure out the first four terms a1, a2, a3 and a4. Now a1 is given as 150. The next term would be a1 plus d, or 150 plus 50, which comes out as 200 rupees. The next term a3 would be equal to a2 plus d, or 250 rupees. The fourth term a4 would be a3 plus d. It comes out as 300 rupees. So the given statement can be written as an arithmetic progression. Rupees 150, rupees 200, rupees 250, rupees 300 and so on.